Hello, everybody. How are you doing? It's me, the pioneers in methods, Mr. Mourad Sultan Ezouidi. Okay, today my kids and my colleagues and so my professor, we are going to explain the strategy using the theorem of Mourad Sultan Ezouidi and using, let's say, the discriminant formula that have been generalized for any n degree polynomial equation or have been also uh, generalized for n-degree linear equation. Okay, today we will start solving 10th-degree polynomial equation, and that we are going to make our conclusion to find out the ninth roots of my new, my nth degree my ninth degree polynomial equation, where the coefficient of the 10th degree polynomial equation is going to be equal to 0. So prepare yourself, and now it's time to start. Just prepare your notebooks or your paper sheet and pens and calculators and start solving the problem to the power n. Okay, okay, okay. We start, my kids. We start. We start. Let's say start and solving. Let's say the. Now I'm going to share first the screen with you so that you can at least follow me and show. Let's say watch the lecture and go step by step. This is now the already, let's say, share the link for solving the 10th degree polynomial equation. Okay, on my channel YouTube. Okay, now we are going to start, my kids. Okay, so we go back here to use. Okay, where your searches 10th degree polynomial equation. This one. Okay, here we have in fact 4 examples. Okay, we try to solve two 10th degree from the equation and also to solve two 9th degree from the equation. Okay, we'll go step by step. Okay, I think example number. Okay, we're coming here first. Example 2, we did it. So prepare yourself, my kids and my professors and colleagues and mathematical teachers and learners to start working out the exact roots of this point to the power 10. Okay, so let's start. Okay, I'll go to the I think fourth or fifth example. Okay, plus one, we did this yesterday. Okay, go. This is also we solved with my kids. Move to the next example. Okay, let's do it tomorrow. I wrote the next. Let's do it tomorrow. So this one, the example. Okay. Yes, this one. Example number 5. Okay. Not done, do it tomorrow. Okay. So I will start doing this, my kids. So prepare yourself. Okay. This is the example. Now we solve it. I will suppose that this one is done. This is 5, of course. Correct. Okay. I will erase like that. Okay. Sorry. Yes. Save this one. Okay. So here, my kids, you already know that in fact is a 9th degree polynomial equation, isn't it? Okay, I will give you 1 minute to read the ninth degree from the equation. Okay, and then you are going to work out the value of the coefficient of the new ninth degree from the equation. Okay, I put this there. It's better I put there. Okay, so now my learners and my professors and my colleagues, and so my students. Here, as you see, it's a ninth degree from the equation, simply because the highest power is 9. So this pair of x can be read as x raised to the power 9 minus 10x raised to the power 8 plus 45x raised to the power 7 minus 120x raised to the power 6 plus 210x raised to the power 5 minus 251x raised to the power 4 plus 205x raised to the power 3 minus 110x squared plus 35x raised to the power 1 minus 5 equals 0. Therefore, this ninth degree from the equation has been written has uh, has been written as x raised to the power 9 minus L042 x raised to the power 8 plus L142 x raised to the power 7 minus L242 x raised to the power 6 plus L342 x raised to the power 5 minus L442 x raised to the power 4 plus L542 x raised to the power 3 minus L642 x squared plus L742 x raised to the power 1 minus L842. Okay. Now, my kids, you can see this one is 9 degree from the equation. In order to find out, let's say, the exact roots of this 9 degree from the equation, no need to use Newton method or rational theorem because it's not applicable in this kind of examples. Okay, and these methods that I already mentioned, will give you error of estimation. Okay, or the approximation of finding, let's say, the roots will be uh, not correct. But if you are going to use the discriminant formula of Mourad Sultan Ezouidi, you will need to catch the exact roots of this 90 degree from the equation. Okay, let's start. Every one of you try to offer, let's say, scientific calculator so that he can calculate with me at the same time. Okay, and go step by step. Okay. Now, as usual, we call that the value of s minus 1 when putting k equal 0 in the discriminant formula of Mourad Sultan Ezouidi is equal to combination n minus 1 n to minus 1 plus 1, which is equal to combination n to 0, which is 1. Also, n minus 1 upon 2 is also 1. Okay. Now we continue. We want to find the S0. To find S0, just put k equal 1 in the discriminant formula of Mourad Sultan Ezouidi. Therefore, a 0 code r equals the sum from 0 to 1, combination n minus r to 1 minus r, n raised to the power r between parentheses multiply 0 code q raised to the power 1 minus r times lr minus 1 equals 2. So this one has to be written in fact as combination. I'll just write like this. Okay, this one is equal, my kids, minus. Okay, copy. It will be n minus what? Minus combination and choose 1 times a 0.2. Or also you can write it plus n and simplify this. Okay, so this is the formula for a 0 code r. Why is going to be equal 0? Then you should ask the question. Either professor or teachers or colleagues, you should ask why the sum of the axes of this new 10th degree, new 9th degree equation has to be equal to 0. Okay? Simply because the sum of the axes is equal to 0. Means x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x8 plus x9 equals 0. That's why s0 is 0. Okay. Now to find my kids So this is a calculation. It will be negative 90 plus 90 is going to be 0 simply because negative 9 choose 1 is 9 times a 0 for the q is 10 plus n times a 0 for the q is 10 minus 90 plus 90 equals 0. Clear? Till now you are in level A. Okay? Today we'll see level B, inshallah. But for today and prepare yourself. It's easy to work through this kind of difficult tasks, okay, while working with mind-relational equation. It's not easy, okay, but regarding to or according to me, according to my theorem that has been written as the sum from 0 to k combination n minus r with k minus r n raised to the power r between parentheses negative and 0 for the q raised to the power k minus r times lr minus 1 for the q will give you the coefficient of this new 90-degree equation. And then you will notice that all the coefficients are different to 0 except a 0 for the r which is equal to 0. Okay. Now, learners, I'm going to find S1. To find S1, you should go to the discriminant formula of Mourad Sultan Ezouidi, okay, and you should substitute k equal to. When putting k equal to, it will be S2 minus 1 will give you S1 over R equal the sum from 0 to 2 combination n minus R choose 2 minus r. N raised to the power r between parentheses negative L0 for the q raised to the power 2 minus r times Lr minus 1 squared. This one is equal to, when r equals 0, it will be combination n choose 2 times L0 for the q squared. When r equals 1, so it will be minus n combination n minus 1 choose 1 L0 for the q raised to the power 1 times L0 for the q. When r equals 2, it will be, let's say 2 minus 2 is 0, so n minus 2 to 0 is 1. That's why it's written n squared, because n raised to the power 2 times L1 for the q. You can see this one, my kids and my professors and teachers and colleagues, that L0 for the q raised to the power 1 times L0 for the q is equal to L0 for the q squared. That's why here it's a common factor. I wrote it here as that. Combination n choose 2 minus n combination n minus 1 choose 1 times the common factor, which is L0 for the q squared. This one will appear for the s subscript k minus 1 of order r plus n squared times L1. So the difference of this is equal to minus combination 1 choose 1, which is in fact 1, times combination n choose 2 times L0 for the q squared plus n squared times L1 for the q. This one you can see it's the opposite of the discriminant of the quadratic discriminant of quadratic equation. Okay, simply because when you are going to find, let's say, the coefficient of the new second degree polynomial equation, you will obtain, you will write your equation as that x squared minus s0 for the q x plus s1 for the q. The 0 is 0, so s1 is positive. When you transfer on the right hand side, it will be negative. Okay. So now I will calculate this, my kids. It will be negative combination 1 choose 1 times combination 9 choose 2 times 10 squared plus 9 squared times 45. This one is equal to 45. So we see that the value of S1 is different here. Okay, we continue. Now I'm looking for finding S2. To find S2, learners, you should put K equal to, in my theorem, as subscript K minus 1 over R equal the sum from 0 to K combination n minus R choose K minus R n raised to the power R between parentheses into the 0 for Q raised to the power K minus R times LR minus 1 over Q. After making your extension, you will get, let's say, S2 written, that is written in its simplest form, which is equal to combination 2 choose 1 times combination n choose 3 times L0 for Q minus combination n minus 2 choose 1 n squared times L0 for the q times L1 plus n cubed times n. Now, I will now use my calculation. I will use my simple calculator, and I'm going to calculate this. Okay. If you want to calculate S1, okay, no problem. Okay, let's go to S1 to be familiar with this kind of questions. So S1, my kids, is equal to negative 1 times, because the combination 1 choose 1, times what? Combination 2 choose 9. 2 choose 9 is 36. Times 100 times Mr. Murad, yes, times 100 plus 9 squared is 81 times 45 times 45. This one, my kids, in fact, is equal to 45. Therefore, S1 is equal to 45. This is the second coefficient of my new 90-degree equation, or relative to the original 90-degree equation. Here in these exercises, we will see that all the coefficients are different to 0, except a 0 for the q, which is always equal to 0 for any integer from equation whatsoever, and equal to 3, 4, 7, 20, 100, 1000, and etc. Now I'm going to calculate what we call the S2. S2, my kids, just use the formula of me and substitute k equal 3. So when r equals 0, it will be minus n to 3 times a 0.2 cubic plus n times combination n minus 1 to 2 and 0.2 squared times L0 for the cube. You see this one? L0 squared times L0 for the q is L0 for the q cubic. That's why we put here into parentheses outside the brackets. Then the difference of this will give you combination 2 choose 1 times combination n choose 2 times what? The common factor, which is a 0.2. The rest, my kids, when r equal 2, which is the 3, has to be have been written as they are not changed. Means minus combination n minus 6 is 1 n squared times a 0.2 times a 1 plus n cubed times a 2. This S2 is general, okay? For any n-degree polynomial equation, S2 has to be written as that, okay? There is no other formula. Even let's say the resultant matrix or resultant discriminant can't give you this discriminant. Okay. Now, my kids, I will just use my calculator and calculate this. We have, okay, we have 2 times, okay, we have 2 times 9 choose 3. 9 choose 3 is 84. 2 times 84. 2 times 84. This is 84. Okay. Times what? Times 10 raised to the power 3. Times 10 cubed. Or raised to the power 3. Minus 7 multiplied by 9 squared, multiplied by 10, multiplied by 45. So minus 7 multiplied by 81, multiplied by 10, multiplied by 45. Then plus 9 cubed plus 9 raised to the power 3 multiplied by 120. So this one, my kids, in fact, is equal to 330. Let's check again. 330. Okay. I'll do it again. So we got 2 times 2 times 9 choose 3. 9 choose what? 2, 3 means multiply by 84. Correct. Multiply by 10 cubed. Yes. I didn't do it. Multiply by 10 cubed. Means raise it to the power 2. Minus 7 multiplied by 9 squared is 81. Multiplied by 10 multiplied by 45 is multiplied by 450. Plus, my kids, 9 cubed raised to the power 3 means multiplied by 120. So this one is equal to 330. So this one is 330. Okay. I'll check again. 330. Okay. I go to my clip. Okay. Now this is 330. Okay. Now I will please I will should repeat this calculation before. Okay. We told 2 times 84. 1, 2, 3, 84 times 10 cubic minus 7 times 81 times 10, yes, times L1, 45, plus n cubed, 9 squared, times 120. Yes, it's correct, it's 330. Okay, but in the, if you cancel this out, I'll just write again 2 times 93 is 84 times 10 cubed, 10 raised to the power 3. Okay, minus minus 7, minus 7, multiply by 81, multiply by 450, equal 10 by 45, plus 9 cubed, okay, raised to the power 3 times 110, 120. So this one is equal to 330. Yes, good enough. Correct. So this is a 330. Now my kids to find, let's say, okay, to find S3, you should immediately or you should automatically put K equal 3 in my theorem, okay? That is labeled or written as S subscript K minus 1 for the R, the sum from 0 to K, combination N minus R plus K minus R, N raised to the power R between parentheses 0 to 2 raised to the power K minus R times L R minus 1 over I could be equal as 3 from 0 to 4, combination N minus R plus 4 minus R, N raised to the power R between parentheses 0 to 2 raised to the power 4 minus R times L R minus 1. I will just now substitute R with 0, then with 1, then with 2, then with 3, then with 4. And I will, let's say, note that, you will note my professor that L0 times L042 is in fact equal to L042. It's a common factor. You should write this as that. L042 raised to the power 4 is the difference between combination N4 and N times combination N minus 1. This one, the difference is in fact equal to negative combination which is 1 times combination into 4 times a 0.2 raised to the power 4 because of the factor. The rest have been written as they are, not changed. Okay, means S3 is a general formula for any integrity formula to do. Okay. Now I will make a substitution. I will try to calculate the value of this and I will try to find 8. Okay. 8 will be my kids. Okay. I will try to use my calculator just to give me a chance. Till you also solve this using your own calculator. I will use my mobile. Okay, I will just repeat the first 184 times 1000 minus 7 by 81 times 450, then plus 9 cubed times 120. Yes, 330, correct. Okay. Now we continue. Okay. So we put that. Okay, S2 is 330. Now I calculate this. This is my calculator. I will erase everything. Then negative 3 times what times 9 choose 4. 9 choose 4 is 126. 126. Times 10 raised to the power 4. Times 10 raised to the power 4. Okay. Then plus 7 choose 2 means plus 21. 7 choose 2 is 21. Okay. Times my kids 81. Then multiply by 100 meaning 8,100 times 45. Minus 6 multiply by 1,200 because okay, because 10 by 120 is 1,200, multiply by 9 cubed, 9 raised to the power 3, plus 9 raised to the power 4, okay, times 210. Okay, this one is equal 3,510. This one equal to 3,510. Okay. Now, my colleagues, it's clear that now if you would like to work out S4, you should use the discriminant formula of Mourad Sultan, the Tunisian mathematical researcher. Okay, and they use this discriminant to work out the value of S4. Okay, so okay, okay. Mhm. Now I will just put k equal 5 in the discriminant formula of me, and this one it will be equal negative combination n plus 5 times L0 for the to the power 5 plus n times combination n minus 1 equals 4 L0 for the to the power 4 times L0 for minus combination n minus 3 n squared L0 for the to the power 3 times L1 plus combination n minus 2 which is 2 times n cubed times L0 for the squared times L2 for the minus combination n minus 4 which is 1 times n raised to the power 4 times L0 for the raised to the power 1 times L3 of 42 plus n raised to the power 5 times L4 of 42. Why there is no combination here? Simply because it will be combination n minus 5, which was 5 minus 5. 5 minus 5 is 0. Therefore, combination n minus 5 to 0 is 1. That's why here it was disappeared. Okay. After noticing that L042 equal L042 times L042 raised to the power 4, means you will tell that this is a common factor. Put outside the brackets like that. Then the difference of this, of negative combination choose 5 and n times combination n minus 5 choose 4, in fact is equal to positive combination 4 choose 1 times positive combination n choose 5. Okay? Times, of course, of the common factor, which is L0 for 2 raised to the power 5 minus combination n minus 2 choose 3. Okay, times n squared times L0 for 2 cubed times L1 plus combination n minus 3 choose 2 times n cubed times L0 for 2 squared times L2 for 2 minus combination n minus 4 choose 1 n raised to the power 4 times L0 for 2 raised to the power 1 times my kids L0 for 2 raised to the power L0 for the q L3 for the q plus n raised to the power 5 times of all the q. Now we will use the coefficient from L0 up to L4 means I will start at 50, 251. Okay. And I will use my calculation. I make substitution here by kids. Okay. Exchange, let's say L0 with 10 and L1 with 45, L2 with 120, and L3 with 210, and L4 is 251. I will use calculator and try to find the value of this. Okay. So we start from the beginning. You have positive 4, negative 4, multiply by 5 to 9 choose 5. 9 choose 5, my kids is 126. Multiply by 10 raised to the power 5. Multiply by 10 raised to the power 5. Okay. Minus 7 choose 3, 35. Minus 35. 7 choose 3. 1, 2, 3. Okay. Times 81. Why? Because 9 squared times 81. Okay, times 1000 because 10 cubic times 45 plus 15. 6 choose 2 is 15. Okay, times 9 cubic. 9 multiplied by 81. Okay, multiplied by 81 because 9 by 1 is 9 cubic. Times we have 100 multiplied by 120. Then minus 5 multiplied by 9 raised to the power 4. Okay. Multiplied by 210 multiplied by 10 means multiplied by 2100 plus my kids 9 raised to the power 5 Okay, multiply by 251. 251. So this one is equal to negative 24,204. You can see the S1 is equal to 0, which is equal to 3,510. The S2 is equal, okay, sorry, S1 is equal to 45. S2 is equal to 3,510. S3 is equal to 320. S4 is equal to negative 24,201. Okay. Now, my kids and my professors, I want to find the value of S5. To find S5, just put K equals 6 in the decimal formula of U, and you make the expansion. And we note that L042 raised to the power 6 is a common factor between the first two terms. So we should put it outside the brackets and make the difference. The difference of this matrix is going to be equal to negative combination 21 times combination 9 to 6 times the common factor. The rest, when R equal uh, 2 and 3 and 4 and 5 and 6, they are written as they are. They have been written or they had been written as they are, not changed. Okay? Now, my kids, I'm going to calculate this one. Okay? You see this one? This is S5. It's written in terms of the coefficient on the highest power. So this is a general. It's general formula. Okay? I'll just change this one if it's possible. A plus, yes, okay, correct. Plus is written here. Plus n raised to the power 6 times applied for the cube. Okay, now I'll make a substitution. Then I should calculate. You see, I just substitute L0 here with 10 and L1 with 45. Of course, L0 is the same. N is 9. That's why it's 9, 9, 9, and 9. Okay. And L2 is 120, L3 210, L4 251, and L5 is 205. I should calculate this. I will read the value of S, S4. I will start negative 5 times 9 choose 6. 9 choose 6. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Minus 84. Minus 10 raised to the power 6. Minus 10 raised to the power 6. Okay. Plus 7 choose 4. Plus 35. 7 choose 4. 7 choose 4 raised. This is 1, 2, 3, 4. Minus 4, 35. Multiply by 81 because 9 is squared. Multiply by 81. Multiply by 10 raised to the power 4. Multiply by 10 raised to the power 4. Good man. Multiply by 45. Okay. Minus 20. Minus 20. 6 choose 3. 6 choose 3. 1, 2, 3. 20. Multiply my kids by 9 cubic. Okay, 9 cubic. I will make, okay, 9 cubic. Multiply by 10 cubic. Okay, 10 cubic. Raised to the power 2. Okay, multiply by 120. Then plus 10, because 5 choose 2 is 10. 5 choose 2 is 10. So plus, I just make plus 10 times 9, 9 raised to the power 4. 9 raised to the power 4. The highest power of my, the highest power of my own equation. Multiply by 10 squared, multiply by 210. Means multiply by 210, then annex to 0, 21,000. Minus 4, minus 4. Multiply by 9, raise it to the power 5. Good man. Multiply by 2,510. Multiply by 2,510. Why? Simply because 251 multiplied by 10 will give you 2,510. Plus, the last plus 9 raised to the power 6 multiply by 205. Okay. This one, my kids, in fact, is equal to 53,445. You see that now S also S5 is definitely 0. And in the previous row, we showed that S4 is definitely 0. S3 is definitely 0. S1 is definitely 0. S0 is equal to 0 simply because the sum of the x's of my new line degree from the equation. And S minus 1 is equal to 1 by convention. Okay, we continue the procedure. I want to find S6. To find S6 is very easy. Just go to the discriminant formula of Mr. Mourad Sultan or go back to the theorem of mine and substitute k equals 7. Okay, this formula, I mean this one. Okay, there are other formula, my kids. Okay, and these formula give you also S subscript k minus 1. Okay, here is written here. But if you want to use, you can use this one. Okay, this formula. SH Ezouidi Mourad Sultan Henry Ezouidi Mourad equal the sum from, okay, I will just write it. I extract that. The sum from 0 to k minus 1, combination p choose k, between parentheses L0 of O dt raised to the power minus k, between parentheses minus 1 raised to the power k minus 1, and raised to the power k, L0 of O dt raised to the power qk plus L0 of O dt raised to the power k. All, of course, I will show the parentheses this one equal to 0. Okay, so let's focus on what is given first, on the theorem of Mourad Sultan to find S0. Therefore, S6 in fact is equal to 0. R, the sum from 0 to 7, combination n minus r to 7 minus r, n raised to the power r. Between parentheses, negative L0 for 2 raised to the power 7 minus r times n r minus 1 equal to. This one is equal in fact to minus combination n to 7 and 0 for the 2 raised to the power 7 plus n times combination n minus 1 to 6 and 0 for the 2 raised to the power 6 times n 0 for the 2. So as you are professor and learners considered, you can note that this one and that is called common approach. I should put it outside the brackets. Okay, so this one and the difference between minus combination n to 7 plus n combination n minus 1 to 6 in fact is equal to combination 6 to 1 times combination n to 7 times the common factor. And the rest, there is no simplification. They had been written as they are not changed. Means minus combination n minus 6 is 5 n squared and 0.42 raised to the power 5 times 1.42 plus combination n which is 4 times n cubed times 0.2 raised to the power 4 times 4.2 minus combination n minus 4 so 3 n raised to the power 4 times 0.2 cubed times 3.2 plus combination n minus 5 choose 2 times n raised to the power 5 times 0.2 times 4.2 minus combination n minus 6 choose 1 times n raised to the power 6 times n 0.2 raised to the power 1 times 4.2 plus n raised to the power 7 times 6.2. So I will just now substitute or replace n with 9. Okay, it will be 9 to 7, simply here. 9 minus 2 is 7. Then 9 minus 3 is 6. Here is 4. 9 minus 9 n minus 4 is 9 minus 4 is 5. Then n minus 5 will be 9 minus 5 is 4. And 9 minus 6 it will be 3. And 9 minus 9 is 0. And 9 to 0 is 1. That's why here it's written 1 times n raised to the power 7 times x6 upon. I will make my calculation like this. Means I will substitute and then I'm going to find the value after S6. To solve any n given equation, you should work out the coefficient of your new n given equation. Okay. Then my kids here, I will raise the value of S5. I will start to find the value of S6. So it will be 6 multiplied by what? Multiplied by 9 to 7. So this is 9 to 1, 9 to 2, 9 to 3, 9 to 2, 9 to 5, 9 to 6, 9 to 7, means 37. Multiplied by 36. Okay. Multiply by 10 raised to the power 7. Multiply by 10 raised to the power 7. Good. Minus 7 choose 5. This is 1, 2, 3, 4, 5, meaning minus 21. Multiply by 9 squared, meaning multiply by 81. Okay. Multiply by 10 raised to the power 5. Okay. Multiply by 45. Multiply by 45. Then plus 6 with 4 is 15. Plus 15. Multiply by 9 cubic meters. Multiply by 9 raised to the power 3. Okay. Multiply by 10 raised. Multiply by 10 raised to the power 4. Multiply by 120. We finish this one. Then minus 10. Minus 10. Multiply by 9 raised to the power 4. Multiply by 9 raised to the power 4. Okay. Multiply by 10 cubed. 10 cubed is 1000. I will write 1000. Multiply by 210. Okay. Then plus 4 choose 2 is 6. Means plus 6. Plus 6 times 9 raised to the power 5. 9 raised to the power 5. Good enough. Times 10 square means 110. Okay. Hello? Hello? No, 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 I'm recording. You need me now? Okay, I will leave it now. Okay? Okay, okay, okay. So, just a moment, I'll check it. Write send me a message. Okay. Okay. So I will give you time to think, to calculate this for my kids till I finish answering my wife. Okay, first of all, I should disconnect from this VPN. Oh no, okay. I'll give you time, my kids, to continue calculating this till I finish, okay? Okay, send me that to my wife. Okay, please. Okay. So we told that we reach here plus 6 times 9 raised to the power 5 times, yes, times 110 square is 100 times 251 times 251. Then minus 3 times 9 raised to the power 6 raised to the power 6 times 2050 times 2050. Why? Because 105 multiplied by 10 will give you 2050. This is minus now plus. Okay, 5 is okay, done, my wife, done. Okay, excellent already. So we continue. We thought that Let me play this one instead. Okay, we told that we continue. So we told that we reach, let's say, minus 3 times 9 raised to the power 6 times 2015, isn't it? Okay, 215 square. What is yes, this one? Minus 3. Plus 9, plus 9 raised to the power 7 times 110 times 100. So this one, my kids, in fact, is equal to negative 56 and 160. Negative 56,160. You see this one? Yes, now to continue finding a 7, I should put k equal 8 in the distant formula of okay. So I will write S7 is equal, S7 is equal, so S7 is equal, my kids, S7 is equal to the sum from 0 to 8, combination n minus r choose 8 minus r, n raised to the power r between 0 to 0 for q, raised to the power 8 minus r times and r of n subscript r minus 1 for q. So this one is equal in fact to combination n choose 8 times 0.2 raised to the power 8 minus n times combination n minus 1 choose 7 times 0.2 raised to the power 7 times 0.2. You see this one? It's the same as that. I put it outside the brackets, and the difference between combination n choose 8 9 and n combination n minus 1 choose 7 is minus combination 7 choose 1 times combination n choose 8. N is the highest power of my polynomial equation. N0 for the 2 raised to the power 8. And the rest, my kids, when r equal 2, and r equal 3, and r equal 4, and r equal 5, and r equal 6, and r equal 7, it will be the same. Okay? It will be the same, not change. So just now, I will uh, I will write my general formula to find the S7 for the R is equal to this. Equal to 5 minus 7 choose 1 times combination n choose 8 times 0 for the 0 for the power 8 plus combination n minus 6 times n squared times 0 for the 0 for the power 6 times 1 minus combination n minus 3 is 5 times n cubed times 0 for the 0 to the power 5 times 4 over 2 plus combination n minus 4 choose 4 times n raised to the power 4 times 0 for the 0 to the power 4 times 0 for the a cube minus combination n minus 5 choose 3 times n raised to the power 5 times 0 for the 0 to the power 3 times n 4 for the 2 plus combination n minus 6 choose 2 times n raised to the power 6 times 0 for the squared times 5 for 2 minus combination n minus 7 choose 1 times n raised to the power 7 times n0 for the 0 to the power 1 times n0 for the 2 plus n raised to the power 8 times 7 for 2. This one, my kids, when n equals 9, it will be n choose 8 will be 9 choose 8. N minus 2 choose 6, it will be 7 minus 7 choose 6. Then n minus 3 choose 5, it will be 6 choose 5. I take that substitution for n equal 9. Now I will use the last formula and I should calculate this. First of all, I should put this here in front of you. like that. Okay, this one I will rearrange it. Okay, I'll put like that. So no need, no need. Okay, I'll go back like that. Okay, I will reduce it till yes, like that. Okay. So my kids here, I should calculate this. After calculating this one, you already note that the value of S7, okay, like that. I will ignore now the value of S6, then I will start from the beginning. Negative 7 multiplied by 9 to the negative 63 times 10, 10 raised to the power 8. Yes, 8, 8. Okay. Plus 7 multiplied by 81 multiply first by 10 raised to the power 6 multiply by 45 minus 6 multiply by 92, okay, raised to the power 3 multiply by 10 raised to the power 5 multiply by 10 raised to the power 5 multiply by 110 multiply by 120, sorry, plus, this is minus plus 5 times between parentheses or make 99 by 10, 90, close the parentheses, make raised to the power 4. Like, complete that, complete. Multiply by 210 minus 4 multiply by 9 raised to the power 5 decimal. Wait, 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 wait. Minus 4 multiply. Okay, 4 multiply, not 4. Shit, how did I did it? Negative 63 multiply by 10 raised to the power 8. Then plus 7 multiply by 81. 9 squared multiply by 10 raised to the power 6. Raised to the power 6 multiply by 45. Good now. Then minus 6 multiply by 92 minus 729 multiply by 10 raised to the power 5. Okay, multiply by 120. 120. And then minus 6 multiply by 720. 10 raised to the power 5 times 120 plus 5 multiply plus 5 multiply by 10 raised, okay, I make multiply by 90, it's like raised to the power 4. Okay, times 210 times 200 okay, okay, take your time. Okay, minus the minus minus 0, not minus 0. No, okay, no problem. I'll make equal, then I will go to historical, and take this one over. So, this is I just, wow. Okay, make I'm gonna make I had a big figure, sorry. Then raise it to the power 8 plus 7 multiply by 9 squared multiply by 10 raised to the power 6 multiply by 45 okay, 45 then minus 6 multiply by 729 because 9 cubed times 10 raised to the power 5 okay times 120 minus 120 plus 5 times I would write 9 raised to the power 4 okay times 10 raised to the power 4 okay to the power 4 then times 210 times 210 minus 4 multiply by 9 raised to the power 5 okay times 10 cubed minus 1000 times 251 plus 3 times 9 raised to the power 6 again, times 100 for 10 squared, right 10 squared. So that the learner of the professor and go step by step. Times 205 minus 2 only multiply by 9 raised to the power 7 times 10 times 110 times 10 times 110 then plus 9 raised to the power 8 times 35 plus 9 raised to the power 8 times by 35 this one my kids in fact is equal to 28,935 okay now the last step to put that to find the S8 we should go back to the theorem of Mourad Sultan and replace k with 9 okay and you will get the S8 means S9 minus 1 is S8 for the R equal the sum from 0 to 9 combination N minus R 9 minus R and raised to the power R between parentheses because of 2 raised to the power 9 minus R times N R minus 1 equal to 2. This one it had been calculated or simplified and the last formula that I really use either you substitute k with 9 decimal formula and then make the extension and simplify where possible, or you will focus on the last one. Okay, because S8 here is written in its simplest form. Okay, in terms of course of n and the coefficient of my original 90-degree formula equation. Okay, now it's a zero. Okay. Okay, so my kids here, I'll just write S8 equal negative combination n equals 9 times L0.2 raised to the power 9 plus n times combination n minus 1 equals 8 times L0.2 raised to the power 8 times L0.2 minus combination n minus 2 equals 7 n squared times L0.2 raised to the power 7 times L1.2 plus what? Plus matrix combination n minus 2 equals 6 times n cubed times L0.2 raised to the power 6 times L0.2 minus combination n minus 4 equals 5 times n raised to the power 4 times 0.2 raised to the power 5 times 15. plus combination elements fraction 4 times n raised to the power 5 times a 0 to the power 4 times a 4 to the minus combination elements 6 with 2 times n raised to the power 6 times a 0 to the power 2 times a 5 to the plus combination and r equals 7 to the combination elements 7 plus 2 times n raised to the power 7 times a 0 to the power 4 times L6 equals to minus combination elements x is 1 times n raised to the power 8 times a 0 to the 2 raised to the power 1 times 6 equals to plus n raised to the power 9 times L8 equals to 2. Okay, so this is the last formula simply because a 0 to the power 9 is a common factor and the difference between n to 9 and n times n minus 1 choose 9 is equal to combination h is 1 times n choose 9. Okay, now n is 9, so 9 choose 9 is 1. N is 9. 9 minus 2 is 7. 7 choose 7 is 1. So this one will be disappeared. Okay, this coefficient will be disappeared or replaced by 1. Okay, so I will apply this. Okay, and I will calculate the value of this. So I will just use my calculator. I will erase now the. I will give you time to calculate S8 matrix. Okay, okay, I'll show this first. So I will give you time 1 minute to calculate this matrix, then I can. Okay. Hello, my professor, Mr. Ali. How are you doing? It's me, your brother, Mourad. Now I am live, okay, explaining my researches and my theorems, okay, to my professors and colleagues and teachers inside the realms, okay, and to everyone in this whole world, okay, because my target is having, let's say, or getting by my side the smartest uh, human being or the smartest, let's say, learner or colleague or professor, okay, and I'm looking to make my theorems and my research spread out as soon as possible. Thank you. Don't forget about what we were talking. Okay, thank you. Goodbye. Okay, we continue because that I will give you time to calculate. Okay, to calculate the S8. Okay, I will give you time and try to figure out that S8 is going to be equal to negative 5,905. I'll give you time, my colleagues. Okay, okay. So we call that. Okay, we call that methods. I'm going to calculate S8. So it will be just 9 choose 9 is 1, 7 choose 7 is 1, 6 choose 6 is 1, 5 choose 5 is 1, 4 choose 4 is 1, and 1 choose 1 is 1. Okay, and what else? And okay, and what else? And 2 choose 2 and 3 choose 2 are that are equal to that. So we need to add them, but in the value of S8 in nth degree from equation should appear it in terms of combination H is 1 times n to the n minus 2 to 7, n minus 3 to 6, and so on. Okay, so it will be 8 times 8 times 8 times 10 raised to the power 9. Okay, minus 81 because 9 squared times 10 raised to the power 7, okay, times 45, okay, plus, plus my kids 9 cubed is 729 times 120, we make 45, okay, 120 times, okay, 10 raised to the power 6, okay, minus 9 raised to the power 4, okay, times 10 raised to the power 5, okay, times uh, 9, 4, 10, sorry, 10, 10, 10, this one, We told, okay, we told 10 multiply. Okay, I will correct this. 9 raised to the power 4 multiplied by 10 5 times. Okay, by 100. I'll make by 100. Okay, by 10. Okay, raise it. Okay, so this one could be 8 times 10 raised to the power 9 minus 81 9 squared times what? Times 10 raised to the power 7 times 45 plus 9 cubic 729 multiplied by 120. Okay, multiply by 10 raised to the power 6. Okay, then minus 9, okay, 9, 81 squared. It's 81 squared. Minus, okay, minus, I'll make 100 squared. I'll explain why. Multiply by 200, 2000, and 100. Multiply by 2100. You see 10 raised to the power 5, I wrote it as 10, 100 squared. It remains 10, I'll multiply this 210 by 10. Okay, simplify the calculation. Plus 9 raised to the power 5 multiply by, okay, by 100 squared. 10 raised to the power 4 is 100 squared. Multiply by 251. 251. Okay. Minus 9 raised to the power 6 means 729 squared. Okay. Multiply by 205,000. 205,000. Because 10 cubed is 1,000. Multiplied by 205, it would be 205,000. Plus 9 raised to the power 7. Multiply by 110. Then the next two units. Okay, 11,000. Okay, minus 9 raised to the power 8 multiplied by 305 and 50. Multiply by 350 simply because 10 by 35 plus 9 raised to the power 5 raised to the power 9, sorry, multiplied by 5. Okay, so this one is equal to negative 5,905. Okay, now we will comes back because 330 is the value of what? 330 come here. 330, 330. We found 330 S2, I think, or S3. Okay, S3 is 3,000. Okay, so S2. S2 is 330. Now it comes here. I will now make my own conclusion. After finding the coefficient of my new 9-degree from the equation, I will write it in terms of, so we told S2 is 330. 330. Okay, so this is my polynomial. Will be 330. This is S2 means minus here. Minus 330 and raise the rest. So now this, my kids, my new 9-degree from the equation has to be written as x raised to the power 9 minus s0 of order r x raised to the power 8 plus s1 of order r x raised to the power 7 minus s2 of order r x raised to the power 6 plus s3 of order r x raised to the power 5 minus s4 of order r x raised to the power 4 plus S5 of order r x cubed minus s6 of order r x squared plus s7 of order r x minus s8 equally. You see all the coefficients of my new 9-degree from equation are different to 0 except as 0 is equal to 0. Okay, because the sum of the x's of my new new 9 degree polynomial. To solve this, my kids, is not easy to solve this kind of questions. Okay, so but if you are going to extend this 9 degree polynomial equation to the original 9 degree polynomial equation to 10 degree polynomial equation, you will obtain immediately as 0 equals 0, as 1 equals 0, as 2 equals 0, as 3 equals 0. But S4 is equal to negative 52 multiplied by 10 raised to the power 5. Okay, equal to 0. And S5 is equal to 0. S6 equal to 0. S7 equal to 0. And S8 equal to 0. Except S9 of all the R is equal to 51 multiplied by 10 raised to the power 10. Okay. Now, sorry, here, of course, we call that, of course, here is going to be 0. This one, S9 is 0 also. Okay. And we'll explain this in the coming if we are going to deal with 10 degree equation. Meaning, the roots of my original polynomial equation has been obtained when you extend this polynomial to the power 10. And finding the 9 degree polynomial equation, the new, and then our conclusion will be like that. So here I now extend my 9 degree polynomial equation to 10 degree polynomial equation. I will obtain that, okay, I will obtain that this one is in fact equal to x raised to the power 10 minus s square or the rx5 plus 0 here, because s0 is 0 plus 0. Oh, shit. Okay, minus s square. Equal 0. Now, my kids, it's clear that, okay, okay, so it's clear that, okay, this is going to be 0 and s9 is 0. Okay, I will cancel this one and make equal. No, okay, no problem. Leave it as it is. So we consider that s9 equals 0 because here s9 equals 0. Okay, now my kids, so therefore I will write my polynomial as p of x raised to the power 5 equal x raised to the power 5 squared minus s squared order r times x raised to the power 5 times x plus, of course, this is 0. Okay, but I put here as s9 equals 0. Therefore, p of y equals y squared minus s 4 times y plus s9 for the r. Okay, to find the second new degree equation has to be written as x squared minus s0 times x, okay, times x plus s1 over the q. Now s0 is equal to 0, but s1 over the q is equal to negative, where is it, equal, yes, equal negative 10 raised to the power 10, simply because minus 10 raised to the power 5 squared. Okay, s4 equal is 4 here is negative, here is negative 10 raised to the power 5. Okay, so it will be negative, between parentheses, negative 10 raised to the power 5 squared plus 4 times 0, because s9 is 0, because it is this one except it's equal to 0. So therefore, it will be negative. So you see this one, x squared minus s0 times x plus s1 equals 0. S0 is equal to 0. It remains only x squared plus s1. So x squared equal minus s1. That's why here the discrete should be written as that. Minus s1 for the 2 equal 10 raised to the power 10. Now I will use y equal s4 plus negative root of negative s1 for the 2 divided. It will be negative 10 raised to the power 5 plus negative root of 10 raised to the power 10. Okay, exponential 2ik5 all divided by 2. I can now, you can note this one is equal in fact to 10 raised to the power 5 times exponential 2ik5 or equal to 0, because minus 10 plus 10 raised to the power 5 minus 10 raised to the power 5 plus 10 raised to the power 5 times exponential 2ik5 equals 0. Now I obtain this one. I will now immediately solve this question. So xk is equal to negative 10 raised to the power 5 raised to the power 1 times exponential 2k I pi over 5. Or the minus 1, this one. Now we like add exponential I pi. Divided by what? Divided by 5. So it will become like that 10, because 10 raised to the power 5 raised to the power 5 is equal to 10 raised to the power 1 minus 10. Exponential 2k plus 1 I pi over 5. Now, these are the x dash subscript k from 0 to 4 is equal to 0, because x raised to the power 5 is equal to 0, therefore x subscript k is equal to 0. Okay, this is the x roots, of my 10 Newton equation. Now, the roots of this, my kids, it will be like that. If I'm going now to solve this polynomial, the xk, this polynomial, this one, the new 90-degree polynomial equation, this one, my kids, this polynomial equation, this one, you see, I'll take, the roots of this are, okay, I'll write them here, yes, I'll put them here. So, the roots of this polynomial to the power 9 that I started with is equal to negative 10, or I will use the formula. So, this is the relationship between 9th degree and 10th degree. L0 for the cube plus S subscript from 0 to 8 divided by 9 equal L0 for the cube plus X dash. X dash is the X roots of my new 10th degree polynomial equation. Okay, from 0 to 9 divided by 10. So, the xk, the x roots of my new 9-degree polynomial equation, this one, it's labeled as xk, equal minus L0 42 plus 9 times x dash subscript k from 0 to 9 divided by 10. Okay, now we make substitution. X from 0 to 4 is minus 10 plus 9 times 10 exponential 2k I pi over 5 divided by 10 means minus 1 plus 9 exponential 2k plus 1 I pi over 5. These are the roots of this new 90-degree polynomial equation that is obtained from the original 90-degree polynomial equation. And the rest will be minus 1. Means this polynomial to the power 9 has a root which is equal to negative 1 and has an order of multiplicity of 5. Okay, or has 5 as an order of multiplicity. Okay, you can, if you want to check. Okay, minus 1 is solution of this. Let's check. Okay, we have. Okay, I will do this one here. I will go down again, 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 again. Okay, I will use my calculator. I will erase everything. We have 1 minus 1 to the top. Minus 1 is to the power 9 is minus 1. Minus 45. Okay, minus 330. Then plus 24 201. Then minus 3510. Then minus, okay, minus 53 minus 53 445. Then plus 56,160. Then minus 28,935. Plus what? 5,905. So this one, if minus 1 is a root, it will be 0. And minus 1 here, it's a root where the order of multiplicity is equal to 5. According to what? According to this. Okay, x from 0 to 4 is equal to minus 1. This is according of the relationship between nth degree polynomial equation and p degree polynomial equation. N is 9 and p is 10. Okay, for the extension. Now, so the roots, my kids, I will use the roots of this. You see this one? The x roots of this new 90-degree polynomial equation are this. I will use them to solve. Means I will add this to 10 because I 0 for the cube second quotient of my nine degree from equation is 10. So I will make 10 plus this, all divided by 9 because I'm working with 10 to the power 9. So like that, data from 0 to 1 to 3 and 4 equal L042 plus the x roots of my new 9 degree from equation divided by 9. So L0 is 10 and xk is minus 1 plus 9 exponential to ki pi over 5. 10 minus 1 is 9, it will be 9. 9 divided by 9 is 1. 9 exponential divided by 9 will be exponential to k. So these are the fourth roots, okay, of my 9 Newton equation. Except 2, because when equal to it will be 0, okay? When k equal 2, it will be 0. 1 minus 1 is 0. And 0 comes when you extend your 9 degree from equation to get a 10th degree from equation. Means that already, in fact, x equals 0 is 0. Okay. Now the other roots are L0 plus xk from 0 to 4. The x the xk 0 to 4 is 0 because x5 is 0. So it will be 10 minus 1 divided by 9 equal 9 over 1 equal 9. So the root uh, means that I have an equal root, 5 roots which are equal which are equal, and the other roots are complex. Means if you are going now to change, you want to check, go back and change x with 1 in this one. Okay, in the original form that we started with my kids. What is it? This one, yes. Okay. Now I will change x with what? This 90 from with origin. Let's start. I will erase everything. So go with me. It will be 1 minus 10 plus 45 minus 120 plus 210 minus 251 plus 200 and plus 200 and plus 205 minus 110 plus 35 minus 5. So this one is equal to 0. Means that, in fact, 1 is a root. Okay? So now, in order to be confused, in order to be appreciated or convinced from where we got the roots, it's very easy. You see here, for a 9 degree from equation, all the coefficients are definitely 0, except a 0 because the sum of 0. The sum of x is at equal to 0. Okay, and we solve this. Okay, now my kids, if you want now to extend this to a 10th polynomial equation, I want first to get a tray. Okay, now I will extend my 9 degree from equation that I started with, and then where I showed that the roots are equal 1 plus exponential 2ki pi divided by 5, and x equal 1. It's a root that has an order of multiplicity 5. Okay, now I will give you time, my kids. Okay, I will just go to pray, and I will come to continue. Okay, I will give you, just give me time, I will come. Okay, just a moment. I will go to pray, then I will come. Then I will come. I will just make like that. Okay. Okay, we continue. Sorry for bothering you. اهلين حبيبي، السلام عليكم. تحب تجيني هنا؟ انا الحين على ابواب اخلص المراجعه. زين. بعدين السلام عليكم، السلام عليكم. انا في البيت. قلت لي تعمل قهوه، باجي لك. بجيب لك الوراق ان شاء الله. زين. So we continue. اوكي، جيب معك الاورديناتور. اوكي تمام ان شاء الله. So we continue, learners. I'll just extend the poem to the power n, and I will immediately go because I will leave now. So I will go to drink my coffee. So this is poem to the power 10. We found all the s subscript k minus 1 is equal to 0 except s4 and except s4. Okay, this one. So okay, my friend, I continue. This is S8 equal okay, and okay. You see, this is now I will write. This is the polynomial to the power 10 is written as that. After making simplification, it will be x p of y squared, p of y equal y squared minus s for y minus plus s9 equal 0. S9 is equal to 0. Therefore, I will obtain that S4 is equal to negative 10 raised to the power 5. I will use my own discriminant. It will be x squared minus S0 42 dash times x1 by k plus S1 of 42. So S1 has to be transferred on the right hand side. That's why x squared equal minus S1 of ODQ, which is equal to 10 raised to the power 10. I will take the square root, means that y equal s4 minus plus negative root of negative s1 of 42 dash divided by 2. So this one is clear that negative 10 raised to the power 5 exponential to k pi or equal to 0. Therefore, the x roots of my new 10 degree from equations I obtained from the 10 degree from equation that is obtained itself by the extension. So it will be beta k from 0 to 4 at 0.42 plus s substitute in 0 to 4 over time over 10, or it will be a 0.42 plus x dash divided by 10. So it will be 10 times plus 0 is 10 divided by 10 is 1. So this is has an order of 5 of multiplicity. And this one is equal to 10 plus 10 exponential to k plus 1 I pi over 5 divided by 10, which will be 1 plus exponential to k plus 1 over 5 times I pi. So these are the roots. Thank you for listening. I'll come one day to explain this because now I'm in a hurry. I should leave. Okay. Now this one it's there. It's done. Suppose it's done. Now we'll move to the next. Okay. Let's see. Suppose that's done. Okay. Okay. This is 5. Example 5. Example 4. Example 5. Okay. So just a moment. Yes, it's one example. Okay, but I'll see. Okay, okay, okay. Thank you for listening. Let's see the pioneers in math. Mourad Sultan is really encouraging you to make this discriminant formula go spread out, go to be spread out, and to be known because it's like strategy, like method that is better than the method of Newton. Okay, because the Newton method will give you error estimation. Unacceleration theorem is not applicable in this kind of examples. Okay, even Python, he tried so many times to solve, but he didn't find. Let's check this one. Comes and solve. Okay, first I should okay, save this. Good night. Now it comes to here. I will make my quiz for that. Okay, Microsoft. Microsoft, you can find it. It's really just okay. So we make graphic. Sometimes he tried, yes. So you see, this graph is false. Why? Because we told that this equation has 5 roots which are equal, means the curve has to go up and down, stopping up and down, okay, and comes to pass through the point 0, 1, okay, 1, 0, sorry, because when x equal 1, y is 0. So this curve is false. Okay, we continue. Okay, let's do this one, please. I will give him the ninth degree from the equation, the ninth new degree from the equation that I obtained, that is obtained here. Okay, this one, yes, this one. Let's see what we can do. He will make also the same mistake. Okay. Okay, no need for this. A new one. You see why we didn't have. Okay. 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 Yes. plus 5. Okay, plus 56,160. Okay, x squared. With x squared. With x squared. Okay, plus 28 minus 35 x only. Then plus 55,905 equal 0. Okay, now I will take this one equal 0 because this is no need. Okay, this is also no need. Okay, save this. Now I'll make like that. Equal 0. Okay, he has to find the x equal minus 1 is a root that has now that multiplicity 5. Do your best. You can do it. This is quite something wrong. Nothing wrong. You, your own step you try is wrong. Haha. Yes. Let's see the pioneers in method. Something went wrong. Please try again. No need to try again. Do this by yourself. Okay, I'll check the equation. The equation. So 45 is equal. S2 is negative. S3 is negative. S4 is negative. S5 is positive. S6 is negative minus give positive. S7 is positive. And S8 is negative minus S8. Yes, correct. It's correct. It's correct. It's correct. Equal to x plus. Okay, it's nothing. It's okay. I will erase and at the time I'll make like that. I'll come like that. Go back and put again. Okay, go back. Try. I will try this. Yes, try. He will say that something goes wrong. Okay. So these are the roots. Okay, where is minus 1? Because minus 1 is a root. So we pass to minus 1. And the other root, only 5 real roots. There is no 2 other real roots. Okay, so we make a mistake. Sorry for interfering and goodbye. Receive the pioneers methods Mourad Sultan is video. Okay, thank you and goodbye. I will close this. Okay, I will also close this.